So consider a vane shown on this figure. So moving with a uniform velocity v, and it is represented by this line. So this is our v1 velocity, v1 prime, and this is our vane. Okay, so that represents the v prime represents the velocity of the vane. Then we have the velocity of the with the same direction. So the velocity of the jet traveling in this direction. So traveling in this direction also the same with the v1 prime. So this will be our v1. So I'm gonna make plus v1. So this will be velocity v1. Okay. So your v1 prime represent as the absolute velocity of the jet. So that is before it strikes the vane natin dito sa part na ito. Then we have your u, so that represents the relative velocity of the jet. So that would be with respect to vane. So with respect to if you are in the vane and then you're going to observe the velocity, so that is the value of your u. So if we're going to show it in the figure, so our u, so it's simply as the line traveling here. So this is our u. So we have here your u. Then we can say, and it can be represented, or u can be represented as our u can be represented as your v sub 1 minus your v prime. Now, by neglecting yung friction, so there will be no friction as the impact of jet from point 1 to point 2. So it means that we don't have the change in velocity we have here. So neglecting that one, so the relative velocity of the jet with respect to vane, so as it passes from point 1 to point 2 is the same. Okay, so in that case, so not all the fluid will be deflected. So there is a part that is still not being passing to the vane but being deflected. So not all the fluid being deflected. So rather than then it will be equal to your volume flow rate, which is equal to your area times the relative velocity of the jet, where your A will be the cross-sectional area of this one. So the cross-sectional area of your jet, or can be assumed as the size of your jet nozzle. So for that cross-sectional area, so that represent yung equation na ito. Now, zooming in the discharge at point 2, we can draw dito. So to have the vertical and component, and also the vector of your fluid in terms of velocity. So we can draw here the velocity of your v. So this will be our v1 prime. Okay, then we shall have also your relative velocity traveling here. So our relative velocity, so that will be along the path of along the path of your jet going out here palapas doon, so that is will be along the path. So you have here your relative velocity, then we have the velocity, or let's say the absolute velocity of the jet as it leaves the vane. So it's the absolute velocity we have here. So we have this one. So we have your B2. So this is your B2. Now what I'm going to do is to highlight this portion and transfer it in a bigger view. So I'm highlighting yung part na ito, then transfer it in a bigger view. So we have now the enlarged view ng kanina. So from here, so kinuha ko yan doon, and then I take it to be an enlarged one here to emphasize yung values natin dito for your components. So I have here your theta, then I have also here U, absolute relative velocity of the jet. Then we have your V2. Okay. So the absolute velocity of jet, so as it leaves from point 2. So I have here your point 2, and we have here your velocity of the vane. Now, so the distance that we have started from here going here, so the velocity component along the x-axis, so let's go here, the x-axis, then we have here for our y-axis, starting here going up there. So I have my y. Now for our x component ng velocity, so we have dito, so that will be your b, sorry, so this will be b2x. Okay, so supposed to be, that will be the distance ng b prime plus yung x component ng angle na ito. So that will be equal now to velocity prime plus, so ano yung magiging value natin dito? So we have taking that of cosine, so that will be ka, so that will be cosine of theta, no? So it's equal now to your adjacent. So we have your adjacent. So let's name adjacent value natin dito. So let's say this is A. So I have here A divided by our U, since this natin ang hypotenuse, that will be yung U natin, which is the relative velocity of the jet. So okay. So we have U, now the value of your A is equal na the cosine of theta times U. Okay, so we can add natin yan dito. So we have your U plus your cosine of theta. So that is the value starting B2 here for your x component, no? Then for our y component, which is this side, no? Yan. So we have velocity 2 at y component is equal now to, so magiging value natin dito at this side, so we can use the sine, no? So we have your sine of theta, which is equal to your opposite. So yung opposite natin, that will be your u divided by So this one is opposite. Is this our sorry, this is let's name natin yung opposite, which is your letter B, and hypotenuse will be U. So we can rewrite our equation for the value of B. So let's say this is the value of your B, or let's say let's change this one to B2 na, yung direct na tayo dito. So let's try to erase this one. So erasing that one. So we have B2Y. Okay, so we write an equation. So the values here, that will be your U, sine of theta. So absolute velocity, relative velocity of the jet times the sine of theta of the angle. So that will be the y component ng velocity at point 2, leaving the jet, leaving the exit place of your vane. Now, for the components of the force exerted by the jet, so we have for your x-axis, so resultant of F of x, so that would be equal to the volume flow rate and density times we have your volume flow rate. Or let's say I'm gonna change this one to Q since ginagawa natin doon. Changing this one to Q, we have your Q prime dito. Then we have the change in velocity now from your B1x. So okay, refer it to the figure. So we have B1 at x. So since it is traveling along the path of the jet, so it's the same as the velocity that we get dito. So we have your B1 x minus the B2 of x. Okay. So yung B2 of x dito sa taas na nakita natin kanina, so we have this one. So that will be the B1 prime plus the U, sorry, so I'm gonna change this one, I'm gonna erase this one. That will be multiply U times the cosine of theta. So we have now for the components of force along the x-axis. Then for the, or we can rewrite this one as the volume flow rate. So we have the specific rate divided by the gravity. Again, the value of this one, that would be B1 of x minus your B2 of x. Now for your y component, for the force acting, so again, we have density, we have your volume flow rate prime. So the volume flow rate prime value niya, we have that one discusses already, that will be the area times the absolute the relative velocity of the jet. So going back, so we have now B1 y minus B2 y, so this is equal now to the volume flow rate, okay, then specific weight, then divided by the gravity multiplied by B1 y minus your P2 y. Then volume flow rate prime natin, Q prime, so it is equal to your area, okay, area of the cross-sectional of your nose of your jet, cross-sectional area nito. Then that will be multiplied by U, okay. So it can be expressed as yung volume flow rate, which is this one, yung quantity of water deflected by the vane, okay. So it can be expressed as the volume flow rate, no, Q, that will be multiplied by the relative velocity of the jet, then divided by the velocity or the absolute velocity of the jet before it strikes the vane. So we have the release of 1 nito. Okay. Then yung U natin, so we have the value of U, remembering that we have the absolute velocity of the jet, no, before it strikes the vane minus the velocity of the vane. So next thing we will discuss now, if the vane is frictionless, so such that the jet leaves the vane with the relative velocity of u. So the same also that kung yung pumasok dito, the same also yung lalabas doon. So there is no friction on the vane surface, but the velocity entering here, or the relative velocity of the jet entering here is the same also, but is going up. Okay. So we have your x component now, so that your f of x is equal to the density. Then we have your volume flow rate that is being deflected by the vane, so that will be q prime. No? Then multiply by your velocity at x component at point 1 minus your velocity component, velocity 2 at the x component. Now our volume flow rate, or the quantity of water deflected by the vane to your prime, is equal to your area times the relative velocity of the jet. Then this is equal to, can be expand by means of the value of this one, so that will be since yung V natin is equal what is entering and what is leaving to the system. So we have your B dito minus your B1 prime. Now to proper discuss ito yung situation na ito, so I draw again I copy again the picture here. Now what we have here, that our velocity, your velocity v1 is equal to b. Okay, so that is what is entering. Then again, our vane moving velocity prime, then our u will be the change in b minus your b prime. So which yung kanina, we have your velocity 1 at the x component now is equal now to your v. Okay, so we can continue our equation, writing the equation dito. So your v2 velocity, okay, so that will be our velocity of the x component is equal now to, so that will be equal to v1 prime, that will plus the absolute plus the relative velocity of the jet times the cosine of theta, which is yung angle dito. So we can factor this out as, or we can expand this one as velocity prime, or let's say velocity of the vane. So yung value ng u natin, that will be velocity of this one minus, this is prime, sorry, this is velocity of the vane minus the velocity of the vane, then multiply by the cosine of theta. Then and then rewriting again our equation, so distribute natin yung values din, that will be velocity prime, multiply mo dito sa loob, then we have v, okay, so that will be cosine of theta, or the velocity of the jet entering, then it will be minus velocity of the vane, that will be cosine of theta. Then we can factor ito tsaka ito, pagsamahin natin, then we can rewrite our equation velocity velocity 0.2 x component, so equal to the velocity of the jet times your cosine of theta. So that will be factor out that the velocity of the plane. So it is equal to 1 and multiply to 1 minus your cosine of theta. Okay. So from a previous kanina in discussion, so we have for the value of f of x, so that will be your equal to your density, no? Then the volume deflected by the plane, volume flow rate deflected by the plane. Then we have the velocity x component and velocity at 2x. Okay, so we can further express our equation natin f of x, so that will be your density. So yung volume flow rate natin na ito that is being deflected by the plane, we have the area times the relative velocity of the jet. Okay, then that is multiply v1 x component, then we have your v2 at the x component. Now we can express in u in terms ng value ng change ng velocity from the absolute velocity of the jet before striking the plane, then minus the velocity of the plane. So we can express this one as your density area, then this will be multiplied to v1, or let's say this will be already b. So since we don't have, the b sub 1x is equal to v. So I'm going to change this one to v, then minus natin yung b sub 1 b prime. So this one, babago, change this one into, so this one will change to v, or the velocity entering at this point, then minus, we're going to change this one, so let's change this one to a bracket one. So we have velocity, okay, so ang value nito we have your, so we have the negative minus the velocity v2x, right? So this one, so that will be b cosine of theta, that will be v1, so this is the velocity of the jet, then velocity of the plane, we multiply by 1 minus your cosine of theta. So para close parenthesis natin yan. Okay, so let's distribute yung sign values dun sa loob. So let's try to galawin mo yun dito sa loob. So we have f of x, so of course in the x-axis we have then density times your area, so velocity of the jet minus the velocity of the plane, and we have the velocity of the jet minus this one velocity, we have cosine of theta, so this will be plus, oh sorry, this minus, so minus velocity of the plane prime, then multiply by 1 minus cosine of theta, then with